Hello, everyone. Welcome. So here we are going to talk about relative frequency. So first, let's read through the problem and then talk about it. Based on the frequency distribution below, find the relative frequency for the class with the lower limit 15. Give your answer as percent rounded to one decimal place. So the frequency distribution table is given here, and we have to find the relative frequency. Okay, we are looking for relative frequency for the class. So these ages, they are given in class because this is a group data. So here we have the class 15 to 18, 19 to 22, and so on. So we have to find the relative frequency, okay, for the class with the lower limit 15. So if we look here, lower limit 15 is there for the first class. That means we have to find the relative frequency for the first class. So we are looking for the relative frequency for the first class there. Okay, that is what we are looking for. So first, we need to know what is relative frequency. So when we say relative frequency, it is the ratio of frequency, okay? It is the ratio of frequency to the total number of observation. So let me write that definition here. Relative frequency is the ratio of frequency denoted by F to the total number of observation, to the total number of observations. So total number of observations in the sample is denoted by n. So for this class with the lower limit 15, so for that class, you can clearly see the frequency is the number of students. So that is 10. So for that class there, frequency is 10. So that is our frequency. Frequency is 10. But what we don't have right now is the total number of observation n. But to find the total number of observations, what we do is we add all frequencies. So let's first find the total number of observation, which is n. So now the value of n, or total number of observation, is equal to, we have to add all frequencies. That means we are adding all these numbers here. So 10 plus 8 plus 3 plus 5 plus 4. So we need to add all these so that the value of n is equal to 10 plus 10 plus 8 plus 3 plus 5 plus 4. That is equal to 40. So the total number of observations is equal to 40. What we are looking for is the relative frequency. So we know what is relative frequency now. We know the relative frequency denoted by RF is the ratio, as I mentioned here. It is the ratio, okay, relative frequency is the ratio of frequency to the total number of observations. So here we can write this as F divided by N. That is the ratio of frequency to the total number of observation. But in our question here, we are asked to give the answer as a percent. So if we want to change this fraction to percent, we have to multiply by 100 so that the result is in the form of percentage. So here in this case, our formula is relative frequency is equal to frequency divided by n multiplied to 100%. Now all we need to do here is plug in the values and simplify this. So that is equal to frequency for that class is a 10. The total number of observations n is 40. That's what we obtain here. multiply to 100, and the result will be in percentage. So 10 over 40 is same as 1/4. So this is same as 1/4 of 100, or 25%. 25%. That means the relative frequency for this class with the lower limit 15 is 25%. Or in other words, we can say that 25% of the data falls under this class. Okay, here we have 25% of the data, 10 of them, that is 25. Out of 40, 10 is 25. So the relative frequency for that class is 25. So that is the end of this video. I hope you got this one. Thank you for watching.